There we go. Okay, we are back in business. So this is the B2 Duo Mk2 that we just did a repair on. The amplifier came in brand new from the factory, and the dealer who took this and installed it into the customer's car said that it was absolutely dead, with no lights, no protection, no nothing. So he was sent it off to me to diagnose, have a look at, and we powered it up on my low voltage supply, 9.8 volts, which 99% of amplifiers work perfectly fine on, and power up to show you the switching frequencies and the rail voltages, etc. And the only 1% of amplifiers that I've come across, like literally two or three in the hundreds of amplifiers I've worked on, don't like powering up on a 9.8 volt supply that I use here. And so when I got this amplifier in, I powered it up on my 9.8 volt supply, and it showed the same issue that the dealer said was the issue with the amplifier. It didn't power up, no lights, no protection, no nothing, completely dead. And so we took it apart and we started doing a repair on it, and it did 2 hours worth of repair. And someone in the chat suggested, you know, try connecting a 12 volt supply just to see. And I was like, actually, that's not a bad idea. I haven't actually tried a 12 volt supply. Let's try a 12 volt supply just to see if this is one of those 1% of amplifiers that doesn't like 9.8 volts. And lo and behold, the bloody thing comes on with 12 volts. So 2 hours of repair time wasted, but no worries. We all make these silly mistakes sometimes. So we're back together again. We're back in the case. Amplifier's been reassembled. So we're going to do a bench test. So there was either nothing wrong with this amplifier from the word go, and it was just a wiring issue with the customer's car, or I did replace the TL494 chip and I did reflow some of the solder joints around that area. So if there was a fault, then I have sorted it by messing around doing that, trying to find the fault that was just the amplifier in protection due to low input voltage. So yeah, that's annoying. Time well wasted. Yes indeed, Basehead 30. So we've got my Dell PSU, my server power supply is ready to go on the workbench. We've got this thing hooked up. Now this is a 12 volt power supply, so we're only going to see the 12 volt power ratings from this, which is fine, that's no problem. We can use square law correction factor to work out what it would put out at 14.4 volts with a decent accuracy. So let's get it hooked up and let's do the bench test. I'm going to change my camera to a decent view so you guys can see what's going on. That looks like a pretty good bench test angle with Audacity in the bottom here. I've got my little warp. That's probably distorting the crap out of you guys, so I'll turn my bass down on my mixer. Apologies. That's a bit better. Okay, so we can do a drop bench test and see what this does at 12 volts. Lovely stuff. You can see on the scope there's no noise whatsoever on idle, which is very, very nice. So what we're going to do is take our little screwdriver so we can increase the gain. And we are going to start pulsing this thing. So you can see there the two waves on the scope. So because this amplifier is in bridge mode, what we have to do is you have to use two probes, one on the positive of one side, one on the positive of the other side. And then the waves on the screen, you can see they're out of phase. This is how bridge mode works. You have the two pluses are out of phase with each other, and they push and pull like this. So we're going to increase the gain slowly. Is that one channel is higher than the other? I should be in bridge mode. There we go, bridge mode active, so they're now both doing the same thing. Okay, so there we had a bit of clipping, so let's back off a bit. Okay, so it looks like one of the channels clips a little bit earlier than the other. You can see there, if I pause the scope, there we go, pause the scope there. You can see that one of the channels is clipping a little bit earlier than the other. It's a higher voltage than the other channel. So this amplifier has a bridge mode switch. So there's a switch on this amplifier which you can press, which turns it into bridge mode, which should duplicate both inputs. Now, by the looks of it here, both the inputs don't look like they are perfectly matched on the scope, because if we check there, you can see that one of the inputs is a higher voltage than the other. which means that in bridge mode it's not completely equal and it won't necessarily do the best power that it can. So what we can do is we can get around that by setting the gains manually so that they're both identical with the bridge mode switch off, and then just increasing the gain on our head unit until it clips. So that's what we're going to have to do. So let's run this again, and we're going to turn the gains right down low. So we have bridge mode off now. So what we're going to do is zoom in on our scope so we can see the waves nice and big. There we go. Zoom in a bit more. Zoom out a little bit. Okay. So as we can see, number 2, channel 2 is higher than channel 1 by about 0.2 of a volt. So what we can do is we can increase the gain of channel 2 a little bit more than channel 1, which will bring them both in line. Let's go back up to that high voltage and start increasing the gains separately. So we'll increase both gains to around about 3 o'clock, and both gains to around about halfway. There we go. I'm going to go both gains to around about 2/3. And we're heavily into clip now, so we're going to back off the gains a bit. Okay. So I'm going to increase the left gain until it clips. Okay. So left gain is in clipping right about there. Okay, now I'm going to increase the right gain into clip. Interesting. The right gain doesn't seem to do anything either. Even with this switch off. Let's depress it again and see if that changes it. There we go. Okay. Now we have access to gain knob number 2. And you can see a little bit of clipping on the second one there now as well. And because we've got a higher output on the second channel now as well, clipping comes earlier on the first channel, so we need to back off the first channel a little bit until we're both dead clean. Okay, now let's start increasing the gain a little bit on the head unit until we're both clipping equally. Okay, channel 2, a little bit of extra clip, so let's back off channel 2 a little bit. Go. So we backed up on channel 2, so now we just increase the gain on the head unit once more. Okay, there we go. So we're now clipping equally. So let's find our exact clip point. On Audacity, you can see here I'm slowly increasing the gain of the output on Audacity, very, very slightly. There we go. That's a little bit of soft clip. So what we're going to do is take the oscilloscope and pause it. There we go. That is our pause waveform. And I can feel that my dummy loads here are getting warm because they're obviously taking power. Got 2 ohms, so this is a 2 ohm bridge mode amplifier. So we've got a 2 ohm dummy loads hooked up here. And that did 28.37 volts on the outputs. So what we need to do to work out what power that did is we need to times that by 2, because this is in bridge mode, so we can see we've got the 2 waves on the screen here. We need to times the voltage by 2 because they are out of phase with each other. So let's do 28.37 times by 2 is 56.74. And now what we do is we work that out for the RMS voltage. So we're going to go to rapid tables, just because I'm super lazy. So we had 56.74 volts, and that was 2 ohms. So that was 1,609 watts RMS at 12 volts. To work that out for 14.4 volts, what we need to do is take the power and the voltage. So the voltage was 12 volts we've got here, so we need to do 14.4 volts divided by 12, which for 12 volts, square that, 1.2 times 1.2 equals 1.44. So 1.44 is our correction factor, so we times that by our power that we saw, 1609.71. So this amplifier just did 2,317 watts at 14.4 volts corrected and 1,600 watts RMS at 12 volts. Awesome stuff. Are we still live? Bad video settings. Please use a keyframe frequency of 4 seconds or less. Currently, keyframes are not being sent off enough. Which perfect. Keyframe. Let me know what the stream looks like, guys. It's telling me that the stream looks bad. It's telling me that the stream health is bad, so let me know if it looks alright. Okay, wicked stuff. YouTube is obviously lying to me. So wicked, yeah, this did pretty good power. Let's just see, I can't exactly remember off the top of my head what power this is meant to do. So let's go to B2 Duo Mk2. And let's have a look on Google what this is actually meant to do. This is a pretty expensive amplifier, so it claims that it does at 14.4 volts bridged. It should do 3,000 watts. Okay, so that's a little bit less. We saw a little bit less than that. We haven't got any 12 volt ratings here. We saw 2,317 watts at 14 volts bridged. Perhaps I'll just try each channel separately for a minute. See if it does its rated power on a single channel. So yeah, we just dropped a bench test and it did about 700 watts less than it claims it does. So I'm just going to check each channel separately because we did a 2-ohm bridge. So I'm just going to check each channel separately in case there was something funny going on. So this will drop to 1 ohm per channel, so that's pretty cool. So we're now wired into 1 ohm on the dummy loads. Just to confirm that, I'm just going to take my multimeter and measure over the speaker output. Yep, we have 1 ohm on the right hand channel. So right hand channel, let's remove our left input, just stick with the right. And get our little gain turny upper. There it is. Let's turn the scope back to run, turn channel 2 off, channel 1 on. Yeah, Josh Hansen, that's right, it is still a lot of power, especially from a Class AB, but it's not what it claims to do. And I know B2 to be a brand that actually does its rated power or greater, so yeah. So this is meant to do 2 times 1500 watts at 14 volts. It's a shame that they don't list the 12 volt ratings here, because then I could compare it more accurately, because I'm running this on a 12 volt supply. Okay, let's do this again then. Power supplies are back up and running, and we have the right gain down here. Let's turn it all the way back down to 0. I'm just tightening this up a bit because I'm not too happy with how the connections are in this, because I'm having to stuff all 4 of the dummy load wires into one of these terminals. I'm just not too happy with the connection, so I'm just trying to strengthen the connection up a little bit in here. I'm a big lover of these great big Class AB amplifiers. I would personally like to run one in my own setup on my base install that I've got planned, and it may end up being a B2. I just have to find one for the right price, and that does the sort of power that I need it to. There we go, that's better. That's a much nicer connection in there now, so. Okay, let's drop the bench test again. Cool. So let's turn the gain up until we find our clip point. There we go, there's our clip point. So you can see there's a bit of soft clip on the wave just at the top and bottom, so I'm just going to try and get rid of that. There we go. I think that's pretty much about good. There we go, 29.98 volts, and that is on one single channel at 1 ohm. So let's calculate that. .98 volts, 1 ohm, 898.8 watts at 12 volts or 1 ohm on a single channel. So to work that out for our correction factor, we need to do 898.80 times by 1.44. That's 1,294 watts at 14.4. So again, it's a bit lower than what it's claiming to do on the web. Any more and this gets pushed into soft clip. So I wonder what percent THD B2 are claiming this to do its power at. I wonder if it says on their website. What's the transistor tester you use? So this little transistor tester that I use is literally from Amazon. It cost me about £20. It has no brand as such. Well, the one on it says EZM Electronics Studio. But yeah, it has no specific brand, but it's very, very cheap and it does the job. Same story with the original DDS2. Never seen one to do actual rated power. Interesting. Okay. So this is the Duo, but I don't know if this is the Duo Mk2 on the B2 website. On the B2 website here, it claims to do 2 times 1500 watts at, oh, here we go, 0.1% THD. So yeah, I can't get rated power out of this thing. I'm not using square law conversion anyway, unless B2 want to give me any 12 volt ratings. Oh, here we go. It does have a 12 volt rating. Power at 12 volts, 2 times 1000 watts, and we only saw 800 and, what was it? Divide that by 1.44. We only saw 898 watts. So we saw 200 watts shy per channel, and about 400 watts shy on bridge mode. That's a shame. I don't think there's a fault with it, because if there was a fault with it, then we would have different clipping on the high and the low rails, which we don't. So, yeah, interesting. Okay, no worries. Well, it definitely works and it does power. It's making my dummy loads heat up nicely. So what I'm going to do next is I'm going to run a 45-minute endurance test on this amplifier, and that will be later, just to ensure that it is solid going forward and it does power for a decent amount of time. And yeah, then it will go back to the customer as fully functional. It's a bit of an annoying one actually, because obviously this probably didn't have a fault at all. So I've just waited about 3 or 4 hours on this, and the invoice to the customer will be very, very minimal because there was actually nothing wrong with it. But never mind. Still made for a reasonable live stream, I hope. So I'm going to lock this one off and I shall start it up again in a few minutes, and we're going to be looking at a solid Audio F2500D, I think that's the next one on my list to repair, which should be pretty interesting. There's a lot wrong with that one as well, power supply and output section. So stay tuned for that one in about half hour's time.